So this question is from 2017 EC. We have to find the Taylor series of this function, right? So we have given these options, and we have to find till power cube, right? So how we can do that? So this fx is equal to e to the power x plus x square, right? We can write it like e to the power x into e to the power x square. Why? Because we know the expansion, the power expansion of e to the power x. So we know the power expansion of this e to the power x square, right? So we can write this, and also we have to write till the power of q. So the expansion for e to the power x is 1 plus x square divided by 2 factorial, that is 2, plus x cube divided by 3 factorial, that is 6, and so on. I'm not considering higher degree polynomials, because even if you consider x to the power 4, that is going to be exceed, right? We have to consider till the power of 3. And how we can write the expansion of this e to the power x square? So at the place of x, what we are going to put is x square. So that is going to be 1 plus x, right? Here it will be x square. Now we will have x to the power 4, so no need to include that, because that will exceed the q. Now do the multiplication. That will be 1 plus x square plus x cube plus x square divided by 2, and plus x to the power 4, no need to include that, plus x cube divided by 6, and again x to the power 5. So it will be there in the series, but we need till x to the power cube. So that will be 1 plus x plus 3x square divided by 2 plus 7x cube divided by 6. So the correct answer for this is option C. So this question is from EE 2016. We have given this as summation, right? And the limit of this alpha, the value of alpha in the range 0 to 1 such that s is equals to 2 alpha is okay. So we have to consider this alpha is from 0 to 1, then this summation is 2 alpha, then what is the value of this alpha, right? So this summation is well known to us, right? And if you don't know this summation, then you will have to look it up and remember this summation here. When alpha is from 0 to 1, right? Then this summation would be alpha divided by 1 minus alpha to the power square, right? And in question we have given this 2 alpha, then this alpha is going to cancel, then we will have 1 divided by root 2 is equals to 1 minus alpha, and from here alpha is equals to 1 minus 1 divided by root 2, that is 1 minus 0.70 something 7. So from here we will have 0.29, right? So the correct answer for this is 0.29. So this question is from EC 2015, and this question is again based on the similar question you have done it, right? So we have to find this summation, and you see here this is n and this is alpha, right? And if you know this summation is nothing but alpha divided by 1 minus alpha to the power square. So that will be 1 divided by 1 minus 1 by 2, that is going to be 1 divided by 4. So that will be 1 divided by 2 into 4, that is 2. So this question is from EC 2014. We have given this series and it converges to, so you see that this series that is summation of n is equals to 0 to infinity 1 divided by n factorial. You can expand it little bit like 1 plus 1 divided by 1 divided by 2 factorial and 1 divided by 3 factorial and so on. So it will look something that you know, because you know that what is the expansion of this e to the power x, that is 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial and so on. Now if you take x is equals to 1, then this will become, so you see this one and this one is similar thing, so that is E. Okay, so this question is from EC 2014. The Taylor series expansion of this 3 sin x plus 2 cos x. This one is also easy, but just you have to know the expansion of the sin x and cos x, right? So expansion of sin x is x minus x cube divided by 3 factorial plus x to the power 5 divided by 5 factorial minus so on, and plus 2. What is the expansion of cos x? That is 1 minus x square divided by 2 factorial plus x cube divided by 3 factorial minus so on. Now you can multiply 3 or 2, so this will give you 2, this will give you 3x. Now here that will give you minus x square, this will give you minus x cube divided by 3 factorial, that is 2. So if you see which option is correct, so in option 1 2 plus 3x minus x, option 2, option 3, option 4. Okay, so I think option 1 is correct. Here it will be minus. So at this place it will be minus, right? So this one. Okay, so you can have a look at these series that are important, right? 10x e to the power x, e to the power x, right? 1 log 1 plus x. So this question is from EC 2009. The Taylor series expansion of sin x divided by x minus pi at x is equals to pi is given by. So okay, so how we can proceed with such kind of problem? So what we can do, maybe we can take this x minus pi is equal to t. So you will see the benefit of taking this x minus pi is equal to t. So from here what we will get is x is equal to t plus pi. Now put in the expression, so that will be sine t plus pi divided by t, right? So that will be minus sine t divided by t, right? Now if we write the expansion of this sine t, we can do that, right? So maybe we can take this 1 by t outside, and the expansion of sine t is x minus x cube divided by 3 factorial and plus so on. Here it will be not x but t, right? So t minus 3 factorial, here tq is there, right? Now we can take this t inside, that will be minus 1 plus t squared divided by 3 factorial plus so on. Now we can put the value of t, that is x minus pi, so that will be x minus pi squared divided by 3 factorial. So this one is not this one, not this one, so option D is the correct one. So this question is from 2008 ME in the Taylor series expansion of e to the power x. About x is equals to 2, the coefficient of this term is, so you will have to do the Taylor expansion of e to the power x about x is equals to 2, right? So that will be fx is equals to f evaluated at 2, right? Because we will have to see the expansion about x is equals to 2 plus f dash evaluated at 2 into x minus 2, right? Plus f double dash f double derivative evaluated at 2 x minus 2 square divided by 2 factorial and so on, right? So first of all, let's calculate this term, these things, right? So f at 2, now f first derivative at 2 and second derivative at 2. Okay, so now okay, we will have to do more because we will have to find the coefficient of this one, right? So that will be so let's write more terms. So at 2 x minus 2, that will be q divided by 3 factorial plus x minus 2 divided by 4 factorial, right? So this is the coefficient, right? So this is what you have to evaluate. Now here it is 4 times. So if you take the derivative of this e to the power x 4 times, that is going to be e to the power x, and we have to find this at x is equals to 2 into 1 divided by this 4 factorial, right? So that is going to be e to the power 2 divided by 4 factorial. So the correct answer for this is which one? Option C. So this question is from EC 2008. A similar kind of question is, so in the Taylor series expansion of e to the power x plus sine x about the point x is equals to pi, the coefficient of x minus pi square is. So again, so we will have to find the Taylor series expansion about the point x is equals to pi, right? So that would be again f evaluated at pi plus first derivative evaluated at pi into x minus pi plus second derivative evaluated at pi x minus pi squared divided by 2 factorial. You see, this is the coefficient, right, of this x minus pi square. So we just have to calculate the double derivative evaluated at pi. So the double derivative would be e to the power x. So I am calculating the first derivative, then after that I will calculate the second derivative plus cos x. Now double derivative would be e to the power. So this one is the first derivative, that is f dash x. Now the double derivative is e to the power x minus sine x, and you will have to calculate at pi. So that will be e to the power pi, and sin x is 0, right? So the coefficient would be e to the power pi divided by 2, so 0.5 e to the power 5. So the correct answer for this is option B. So this question is from again EC 2008 EG1. Which of the following function would have only odd power of x in its Taylor series expansion about the point x is equals to 0, right? So if you know the expansion of sin x, then you know the expansion of sin x cube, that is going to be x cube minus x to the power q to the power q divided by 3 factorial. So you see that here power is odd. Now if you will check this, that power will be even here also, here also. The correct answer for this is option A. Okay, so let's look at this question, that is from EC 2007. We have given this mod that is very less than 1, and we have given this cot hyperbolic x can be approximated as, right? So let's look at this, how we can solve this. So we have given this cot hyperbolic function, we can write it as cos hyperbolic divided by sine hyperbolic, right? And we know that the e to the power form of these two, right, that is e to the power x minus, not minus but plus, e to the power x divided by 2, whole divided by 2, right? For sine it is e to the power x minus e to the power minus x whole divided by 2. So that 2 is going to be cancelled anyhow. We will left with e to the power x plus e to the power minus x divided by e to the power x minus e to the power minus x, right? And we know the expansion of these e to the power x, right? So let's write it down. So expansion of e to the power x is 1 plus x plus x square divided by 2 factorial, right? And we can ignore other terms, right, because this x is very less than 1, so that will approach to 0. So that is one thing. And plus, what would be the expansion of this e to the power minus x? That would be 1 minus x plus x square divided by 2 factorial, right? That we can write divided by, with the same, x square divided by 2 factorial minus 1 minus x plus x square divided by 2 factorial. Now here we will have this x cancel, 2 plus x square divided by this will get cancelled, and this will get cancelled, and here we will have 2x, right? Now we can write this as 1 divided by x plus x divided by 2. Again you see that this x is very less, so we can approximate it as, so this quantity is going to be less, right? And we can that the approximate value of this would be 1 divided by x. So the option C is correct. So this question is from EC 2007, right? And we have given that for the function e to the power minus x, the linear approximation around x is equals to 2 is. So we need to find the Taylor series expansion about the point x is equals to 2 of this function e to the power x. So let's do that. So that about this point x is equals to 2, the Taylor series expansion would be function evaluated at 2 plus first derivative evaluated at 2 into x minus 2, right, plus double derivative evaluated at 2 x minus 2 squared divided by 2 factorial, and so on. So we will have to look at this linear approximation, right? So we do not need to consider this square, but let's do that. So f2 will be e to the power minus 2 and f dash x will be e to the power minus x minus, and at x is equals to 2 it will be minus e to the power minus 2, right? So we can write this as e to the power minus 2 plus, that will be not plus but minus e to the power minus 2 x minus 2, right? Now we can take this common, e to the power minus 2, and that is going to be not the common but this is e to the power minus 2 minus e to the power minus 2x plus 2 e to the power minus 2, so that is going to be 3 plus, not plus but minus x into e to the power minus 2, right? So this is the linear approximation of this e to the power minus x around the point x is equals to 2. So the correct answer for this is A. So this question is from 2000 CE, the Taylor series expansion of sin x about x is equals to pi by 6. So similar kind of question. So we can, what we can do, we can find the first of all what would be the expansion, that will be function evaluated at pi by 6 plus first derivative evaluated at pi by 6 into x minus pi by 6 plus second derivative evaluated at pi by 6 into x minus pi by 6 square divided by 2 factorial 2, right? Now we can find this f at pi by 6, so that is sine pi by 6 sine 30 degree 1 by 2, and f dash x is cos x, and cos pi by 6 is root under 3 by 2, and f double dash x is equals to pi by 6. So f double dash x is going to be minus of sine x, so that will be minus 1 by 2, right? Now we can put all this value to this, so that will be 1 by 2 plus f dash is root under 3 by 2 into x minus pi by 6. Now we will have here, due to this 2 and this 2, that will become 1 by 4, so it is visible, right? Option A is the correct one. Okay, so this question is for you. The third term in the Taylor series of expansion e to the power x about a would be, options are e to the power a x minus a, e to the power a divided by 2 x minus a whole square, e to the power a divided by 2, e to the power a divided by 6 x minus a whole cube. Let me know what's the answer for this question. That is all about the Taylor series. Thank you.